Page 7 in your packet, percent applications, 1F. So page 7, write an algebraic expression that can be used to get this answer in one step. So we're going to be using method 2 mostly. Algebraic expression. Expressions do not have equal signs. Equations do. So no equal symbol if it says use an expression. Find the discount or the sales tax. The cost of an item is C. The discount is 30%. So yes, we always change the percent to a decimal and multiply. So you can see here's the expression. 30% changed to a decimal is 3/10 or 30 hundredths. The cost, I don't know what it is, I'm just representing it as C. So you could either use the 3/10 C, because yes, you would take 3/10 to find the discount, take the percent, multiply it by whatever that cost is. If the shirt cost $20, you would multiply it by 20. If the jacket was $82, you would multiply 3/10 times 82. Or you could use the fraction if you want, 3/10 times the cost. Example 2, the cost of a TV is C. Maybe it's $600. We're just calling it C. The sales tax is 8%. Well, change the percent to a decimal and multiply. So 8 hundredths C, or the fraction 8 hundredths C. That's how we would find the tax on a television set. The cost of a pen, P. The markup is 60%. The cost of a pen, P, the markup. So if I want to find the markup, I would change the percent to a decimal and multiply by whatever the cost of the pen is. So I could show it as 60 hundredths, those of you that like to leave the 0 there, and notice it's a capital P. Or I could say 6/10 P, or I could say the fraction 6/10. I could use the fraction. I almost always change it to the decimal. Number 9, the original price of concert tickets, lowercase c. I don't know what it is. Could be $85, could be $120, could be $10. The discount is 21%. So the expression I could use is change the percent to a decimal, multiply by the cost C, 21 hundredths, or I could say 21 hundredths times my C. I could use the fraction as well. I usually don't though. Find the total cost. Now that's different. This is method 2. Method 2, where I'm going to find the total cost. I'm going to use method 2. So I'm going to add or subtract. Add if it's tax, add if it's tip, subtract if it's discount, subtract if it's a markdown, for instance, subtract if it's a decrease, add if it's an increase. So I'm going to add or subtract from the 100% to start with. I'm going to do method 2 here. Find the total cost of an item. So the cost is C. I don't know. Maybe it's 60, maybe it's 80, maybe it's 90. We're just going to call it C. The discount is 30%. So I'm going to subtract my 30% from 100%. And it gives me 70%. This is method 2. So changing that to a decimal, I get 7/10 times whatever the cost of the item is. 60, 70, 80, 90, 14, 15, 99, I don't know. Or I could use the fraction 7/10 times the cost. Either way. Cost of a TV, it's called C again. Maybe it's $400, maybe it's $800, maybe it's $99. Right now it's just C dollars. The sales tax is 8%. Tax gets added. So I'm going to add the 8% to the already 100% that I have to pay for the TV anyway, and I get 108%. Change my percent to a decimal. I get 1 8/100 times the cost, which you can see there, it's right there. Or I could use 108 hundredths. I could use that fraction as well, times the cost. I would use the decimal. The original price of a book B, the discount is 45%. Well, discounts are taken off. It's what you save, so I'm going to subtract. To get my percent is 55%. So changing my percent to a decimal and multiplying by the cost of the book. Well, the book is costing B. Number 11, the original price of a lizard. You're going to buy a lizard at the pet store. The discount's 40%, but the tax is 6%. Well, the discount, you save it, so you subtract a discount, which would give me 60%. The tax gets added, so 100 plus the 6%, tax is added, would be 106%. Oop, I'm already changing it to the decimal. So in one step, my lizard is going to cost me, change my percent to a decimal, the 60% becomes 6/10. Da-dum-da-dum. Move it back, right? 60%. Go back to, that's going to give me 6/10 or 60 hundredths. And my tax, my 106%, I'm going to make some more room here. So my 60%, plus I got to add my tax on. And I've got to find those percents of the lizard, whatever the cost of the lizard is. So moving my decimal back to, I'm going to have 6/10 for the discount, because that's what it's costing me, 60%, times my 106%, move it back to, times the cost of the lizard. So the percent of cost, I'm going to pay 60% because it's 40% off. That's what a discount is. Plus I'm going to pay 106% because I have to pay all of the cost of the lizard plus 6% more for the tax. So I could do that in one step, multiplying 6/10 times 1 600 times the cost of the lizard, L. Percent of error, page 8 in the packet. Sometimes in the real world we estimate a quantity. When we compare our estimation to the exact value, we find how far off we are. Oops, I made a mistake. I didn't measure very well. What are we really finding is called percent of error. So sometimes we think, oh, you know, it looks like there's about 40 people in the audience. Then you go to count them and there's only 32. Look, I was off a little bit. Or I measure my string that I'm going to attach to a kite and I think it's 6 feet 5 inches, and then I go ahead and measure it and it's only 6 feet 3 inches. Oops, I was off by 2 inches. So that's what we're talking about today. Oops, we were off a little bit. So it's very similar to percent of change. It's very similar. There's a difference. There's a subtraction that we're going to do. We're going to subtract and find out what our oops is, and then put it over the real value that it's supposed to be. So it's kind of like percent of change, where you're going to do a subtraction. Here we do difference. With percent of change, we did the difference, how things went up or down, over the original. Well, now percent of error, it's the difference. What did we count wrong or measure wrong or estimate wrong over the exact thing? The report stated that the parking garage held 240 spots, but in fact, when they counted them, there were only 200. Well, that's not right, 240. So my percent is going to be the difference over the exact. Well, their difference, 240 minus 200, over the exact. There were only 200. There is exactly 200. So it's 40 over 200. Oh, I've got a fraction. Now I'm going to do F to D to P. Well, I could divide them both by 10 and get 4/20, which is the same thing as 1/5, or 4 divided by, change a fraction to a decimal, divide. I get the decimal 2/10 multiplied by 100. That's going to be 20%. So there was a 20% error here in that report. 20% is the answer. Number 2, I thought I would get a 70% on the test, but I really got an 80%. Oops, yay, I was wrong. So my error is 80 minus 70, the difference over what did I really get? Exactly 80. So it's 10 over 80. Well, that's just 1/8. 1 divided by 8 on a calculator gives me the decimal 125 thousandths. 1, 2, F to D to P. Divide, slide it over 2. You get 12.5% was the error. You did 12.5% better than you thought you were going to do. I expected to receive $50 for my birthday, but I only got 35. Darn. I expected to get 50, but I only got 35. Well, I'm a little short. What is the percent of error in my expectation? Well, take their difference, put it over what you really got, the actual 35. Their difference is 15 over 35. 15 divided by 35 gives me a repetent decimal. 4, 2, 8, 5, 7, 1. That's the trying to memorize that repeating decimal. 4, 2, 8, 5, 7, 1. There we go. That's the repetent decimal. Yes, this is a repeating decimal when you get that. Well, we've only got to move it over to 1, 2. We get 42 and 8/10, or rounding it approximately because it's an 8 with a 5 sitting next to it. I would say your percent of error is about 42 and 9/10%. Exactly, it's 42 and 6/7, actually. I could change it to the mixed number, 6/7, but 42 and 9/10, good enough. I rounded it to the nearest 10th. Jim expected 24 people to come to an interview for a job, but only 18 people showed up. So he was wrong. His expectation was off a little bit. How far off was he? Take their difference over exactly 18 people showed up. Well, 6/18, you probably recognize that fraction as 1/3, yes, does equal 1/3, and this is one of the ones you're supposed to know. You're memorizing these, and we get 33 and 1/3%, because 1 divided by 3 is 3/10 repetent. So he was off by a third, a 33 and 1/3% off. And we're going to practice more percent error and more problem of the day kind of questions, writing expressions and equations in class tomorrow.